Okay, welcome back, wonderful Algebra 2 students. Today should be still Thursday the 10th, or maybe it's Friday the 11th. This is the beginning of the second set, so it's EOC Subpart 2. There's 20 questions in this, and a calculator is allowed. And a quick reminder, you have to turn in your work for all of these. Please label it just like it is in Google Classroom. So label it at the top, EOC Subpart 2, 1 through 20. Gotta see your work, all right? So like if Evan and Faith and Chloe are all working together over here, you got to turn in some work while you're doing your answers. Because remember, the goal is just not to get a list of answers. I already have the answers. I know what those are. All right? The goal is for you to understand these problems, okay? So, without further ado, we'll go through this set of 20. This shouldn't take too long. Only one, I just worked them all just to make sure, because hey, does every Algebra 2 student does every Algebra 2 teacher in the country know how to work every Algebra 2 problem in the country? Of course not. We run into things that we are a little confused about all the time. You've seen me consult with Mr. Miller, and every now and then he is a little confused by what I have trouble with, which makes me feel better, obviously. So I run into trouble on these sometimes. I didn't create the problems. I just downloaded them for all of us to practice with, all right? Okay, so without further ado, let's start number one here. A school district wants to know whether there's a relationship between students, standardized test scores, and the amount of time they spend on extracurricular activity. They survey students from each of the schools. Done. All right? They survey students from each school in the system to gather data about the average number of hours. And I'm going to double check that because maybe census, the word census, might imply that they surveyed everybody. Let's take a look at that. It's definitely not observational study. I think that answer is actually wrong. Why would that be? Hold on, let's read it again. Maybe I didn't read the whole thing through, okay? Survey students from each school in the system to gather data about the average number of hours. Yeah, so they didn't, I disagree with that answer. Observation, they didn't watch the kids. They didn't sit in the hallway and take notes. They didn't sit in the classroom and take notes. They surveyed them. It said it right there, all right? So a census is typically a survey that involves the entire population, and then a sample survey, they may only ask 100 kids. Since they asked everybody, I'm going to go with census on that one. All right, let's move on. All right, you may remember this from our work with complex numbers, all right, square root of -1, I, all that kind of stuff. So, there are only 4 possibilities for I to an exponent. I by itself, I squared, which is -1, I to the third, which is -1 times I, because it's just those two multiplied together, and I to the fourth, which is I squared times I squared, which means -1 times -1, which is 1. And then you just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because I know that every every multiple of 4 lands here, I'm going to call that 40 and call that 41. I'm going to go with I on that one. Okay? All right, moving on. Solve for x. Now, you can immediately see, what do these answers look like? Unfortunately, they look like answers when you use the quadratic formula. So, we're going to use the quadratic formula on this thing. First, we've got to put it in order. 6x squared minus 12x plus 11. So, negative b plus or minus the square root of b squared. That's going to be 144 because that's -12 squared. Remember, if you use your calculator on that, to put the -12 in parentheses. All right. 144, that's b squared minus 4 times a times c is 11. So that's 24 times 11, that's 240 plus 24. So 144 minus 240 plus 144 is 264, I believe. I better check that on a calculator. 24 times 11. Yep, 264. So, sorry, I should have gone ahead and done the denominator, but I know that that's over 2a, which is going to be 12. This is going to be 12 plus or minus the square root of negative 20 over 12. The negative 20 is going to turn into, I'm going to split it up into negative 1 times 4 times 5. The 4 has a square root, it's 2. The negative 1 has a square root, it's I. The 12 is still out here at the beginning. This 12 is still underneath. I can cancel the 2 in all three terms. So I got a term here, here, and here. So I ended up with 6 plus or minus I on the square root of 5 over 1. So let's see if that's one of the answers, or I could have made a mistake. Oh, we only canceled a 2 out. We only pulled a 2 out. So I made a quick mistake, but I noticed that by looking at my answers. We only pulled a 2 out of each one of those. So that canceled, these canceled to 6's. So it's 6 plus I on the square root of 5 over 6. Still not an answer, all right? Still not an answer. It's a little embarrassing, but I made a mistake here somewhere. So I'm going to have to restart as quickly as possible. Uh-oh, where did my tools go? It crashed. I'll be right back. I don't want to stop the video because then I have to post 2. Be right back. Be right there. Just starting back up. All right, I probably will split the video up just so the file size isn't so big. But I'm going to have to do this one again real quick because I messed up somewhere. So 6x squared minus 12x plus 11. Maybe I had minus 11 before. All right, let's take a look. So negative b plus or minus the square root of b squared minus 4ac. All right, so 144 minus oh, that was 264. There's my problem. So I ended up with negative 120. Let's go ahead and do it over 2a. So I ended up with 12 plus or minus negative 120. I had negative 20 the first time, all right? So I realized from the answers that obviously I had done something wrong. So there's 12. I'm going to split this up into, let's see, what's a factor of that? 4, negative 1 times 4 times 30. 30 doesn't have a factor that has a square root, but 4 does. Square root of 4 is 2. Square root of negative 1 is I. We pulled those out of the radical sign. A 30 is still left over in there, and it's over 12. So cancel, cancel, cancel. We end up with 6 plus or minus the square root of I on the square root of 30 rather, over 6. Plus or minus I on the square root of 30 over 6. So we'll go with option 2 on that one. All right? All right, moving on. That took a few minutes, but the next ones will not. There are several that simply do not take a few minutes. This, you'd be crazy not to just throw this in your calculator, and then you got to understand what the questions are asking, okay, what the possible answers are asking. So let's put this in the calculator. It's basically going to look like upside down, clear, clear, clear. Actually, let me grab another calculator because that one has 5 functions plugged into it for one of the future questions. So, negative x squared minus 6x minus 8. Let's see what the thing looks like. It's about at negative 3 comma 1. And it looks like this. So it opens down. The minimum value, we don't have a minimum, we have a maximum because it opens up. So we need it's either going to be this one or this one. The max value is where y equals 1. That's it right there. So x does not equal 1, x is negative 3 in this case. You can see it right on the calculator. And we don't have a minimum or a minimum, and it doesn't open up. So we're done. I told you, these later ones, I know we're only on number 4. Believe me, that's kind of exhausting for me too. But they get easier as we go, which is, I'm not sure if that's the case for the real one, all right? This is just a random selection. So, given the polynomial, determine the values of x where the graph of the polynomial crosses the x-axis. Another graphing one, we can simply plug it in the calculator, 2x squared plus x minus 15. And we can see that it crosses at negative 3 and positive 2.5. There it is. If you want to be absolutely sure, if there's a couple of answers that are close together, use your second calc or the trace button, second trace. Use your intersect and find where, use your zeros, I'm sorry. Where it passes through the x-axis is your zeros. Where it intersects with another line or another function is intersect, all right? So use your zero function on that calculator. All right, moving on. Only 15 more to go, and these go quickly. Caretaker at the zoo studying the effects of a new diet. She continues to feed half the elements their existing food, switches the other half to a new diet, monitors the health. This is an experiment because she made some changes. And then did observation on those changes. So because she acted on it, that makes it an experiment. And we'll double check here. Yep. All right. Next one. Given this, I saw this one earlier. This one can seem a little tricky. It reads a little tricky, but it really isn't that bad. First of all, it's an easy one to plug x and y into, all right? Because they're telling us that x, whatever x is minus y, times whatever x is plus y, is the same thing as 52 times 48. So I just saw in my head that these are 4 apart. So if x were 50, 50 plus 2 would give us this 52. 50 minus 2 would give us that. So I believe that answer is C. Let's check it real quick. Yep, that would also be a good candidate for plugging in all of your values right in here. Just plug it into one side because we know they're equal. Whichever side's easiest, actually. This one might be easiest, 50 squared minus 4 squared. And then make sure it's equal to 52 times 48, all right? Okay, the fourth term of a sequence is 108. So we don't know the first 3 terms, but we know it's 108 is the fourth term. Each term after the first is 3 times the previous. So we're multiplying by 3 as we bounce from number to number. So how can we figure out what the missing numbers are? Easy, we just divide by 3. It ends up being 36, 12, and 4. And then our formula, if you remember, a sub n equals a sub 1 times r to the n minus 1. Now, to write the explicit formula, explicit function or explicit formula, you just substitute in a sub 1 and r. So we know a sub 1 is 4, we know r is 3, n minus 1 is still a variable, so our answer ends up being option 3. Be careful, this one's a lure. Mr. Miller called it an attractive distractor, all right? All right, so let's double check that. Yep, option 3. All right, there it is. Okay, this is where they start getting a little more straightforward. Undefined, in math, it just almost always means where is the denominator equal to 0. So, if we ask the denominator, when are you equal to 0? We can just solve it, and x would be equal to -6. That would give us 0 on the bottom of a fraction. That's undefined, okay? Moving on, almost half done, and this goes a little quicker as we go. Trust me on that. It took me forever to do the first 5, and then the next 15 were about the same amount of time. We did this one in class. Which expression is equivalent? That means we have to factor the top. What multiplies to get that and adds to get that? The answer is 6, positive 6 and negative 4. Okay? And then the bottom is factors into 3 times x plus 6. The x plus 6's cancel, and our answer is x minus 4 over 3. We did this one just the other day in class, I think. All right, moving right along. This one's not fun, but it doesn't take a lot of time. They give you a formula for the height of a rock at every millisecond as it's dropped from a hot air balloon, okay? The question is, what's the average rate of change in meters per second of the height of the rock? Now, everything's in meters, so we don't have to do any conversion. Between 2 and 4 seconds. So what we're looking for is the change in the height in meters, the change in the meters over the change in the seconds. Now, my change in the seconds I know is 2 seconds, all right? So I already know that, from 2 to 4 seconds. Now, we just need the height at 2 seconds and the height at 4 seconds. We plug it right in there. So let's do that real quick. Negative 4.9 times 2 squared, well, I'm just going to do times 4, plus 100. At 2 seconds, it is at 80.4. And at 4 seconds, times t squared at 4 seconds, that would be 16, plus 100, minus 21.6. Go grab that 80.4. minus the one above it. 58.8 is how far it went in that 2 seconds. Divide that by 2. Our answer ends up being 29.4, or C. All right? Harder than it actually is. It reads harder than it is. Okay. 2 students work the same problem. This is just analysis, y'all. This is just analysis of how 2 people solved a not particularly simple rational expression equation, all right? So let's study what this dude did. He wrote the problem. Oh, no, he didn't write the problem. He canceled the 5 and the 5. Ooh, I don't like that. He canceled that 5 and the 5, but you can't cancel across something that is added. You can only cancel things that are multiplied. If you cancel across something that added, you got to cancel in all 3 terms. So he already did something wrong. So let's see what this guy did. He cross-multiplied and then got the x's on the same side and then got the numbers on the same side and did it properly. So Jamie did it improperly. Taylor did it properly. Let's see what our possible answers are. Taylor is right. Jamie is wrong. So it's either one of these, all right? We got to read these carefully. If Taylor is right or Jamie is wrong, those are kind of the same thing, but we got to read the rest of it because 1 times 2x plus 5 equals 5 times x plus 3. That's this step right here where he cross-multiplied is one method to solve a proportion. So I like that, but I'm still going to read R. Jamie is wrong because from step 2 to step 3, she should have added x to both sides. Step 2 to step 3. No, she shouldn't have added x to both sides. She was subtracting x, so we can mark off that answer. We're going to go with P on that one. P. All right, just some analysis skills there. What value of t makes the equation true? All right, I looked at this earlier, but I didn't solve it, so let's see how bad it is. Equals 12. We're solving for t, so let's get this expression by itself. We're going to divide both sides by 4. Get rid of that 4. 10 to the 3t now equals 12. So what do we do here? We can plug our answers in. Let's just plug those 4 answers in real quick. 10 to the 3 times 0.2. Is it 12? It is not. 10 to the 3 times 0.16. That's not 12. 10 to the 3 times 0.22. That is not 12 either. I'm going to go with 0.5 to the 3 times 0.5. That's 31. So what have I done wrong? Oh, I forgot to divide by 4. Why didn't you guys tell me? You got to watch this stuff. Troy, Jack, I would have thought you would have said something while I was solving that. All right, so that's 3. So I'm looking for the one that's 3. Fortunately, I already solved it to the nearest hundredth. So I'm going to go with 0.16 on that one. And let's double check. Yeah, it is 0.16. All right, very good. Let's keep moving. Only have 7 left on this one. And this one takes about 10 seconds, y'all. Let's watch. The graph is shown. Look, it's a system of equations. You should immediately think, anytime you think of the graph of a system of equations, you should think, oh, where they cross is the solution, right? A system of equations, if we're going to graph them, where they cross is the solution. Here's where they cross. Now let's see what it asks us. What are the x values for the solution? Yeah, it's right here. The x value there is 0, and the x value here is 2. So we're going to go with D on that one. All right? Select each function, 15. We've got 3 answers. Oh, this is the one that I switched calculators for because I just plugged all 3 of these in the calculator, all right? Now, we did not talk a lot about inverses. So this might be a question that we would all have some trouble with simply because I didn't cover it maybe the way I should have. That's going to happen with a skill from time to time. You know, it's hard to know exactly what's on the EOC from year to year. And even this year, this skill might not be on it. But all I did, I typed each one of these into my y equals. I got 5 different graphs. And I'll admit, I had to Google what the inverse does to a graph. All right, so what it's asking is, select each function that has an inverse. Well, we studied inverse a little bit, but we found it rather cumbersome and difficult to get. But what I didn't cover is what inverse does to the graph. So we're looking for a function, what inverse does to the graph. This first one ends up being basically a parabola. And what an inverse does is it reflects the entire thing around this perfectly diagonal line, y equals x. So it reflects it around it. So this one would end up looking like this, which is not a function. So we can cross off that one, all right? This one, the next one, ends up just being a line, and a line reflected around the y equals x looks like that. That is still a function. This is another line. The inverse of a line is still a function. This next one looks like this, and if we reflect it, it looks something like this, which is still a function using the vertical line test. And then the last one ends up looking a lot like a parabola. When we spin it on its side, it is not. So we're going to go with all 3 of these middle ones here, all right? The lesson there being, this is something we didn't cover in depth, what the function of the inverse looks like, but what it does is reflect it around that y equals x, that diagonal line, okay? All right, simplify. These go very quickly. Cube root of negative 27, that would be calculator work, and you're going to get negative 3. We don't even need to use parentheses on it. We're just plugging it into our main screen here using our math and then our 5th thing down because we need to do cube root. And then we'll put a negative 27 in there. We get negative 3, and we're done. All right? Moving on. Very similar problem, except unfortunately, the calculator won't help us much with this x to the 6th. We're going to have to remember how to take the cube root of something that is taken to an exponent inside the root sign. So, I don't know if you remember this, but we divide it. So, we divide it by the 3. So the cube root of negative 64, you can do that in the calculator. I'm just going to grab the one that I just did and change the 27 to a 64. I get negative 4. I get negative 4 for the cube root of 64. So it's now out of the cube root sign. And the x to the 6th is still in there. And then we divide the 6 by the 3, and the cube root of x to the 6th is x squared. So our answer would be negative 4x squared, or C. All right? All right, 3 more. 3 more. Remember, you got to show your work on this stuff. All right? Okay, this is very similar. Square root of negative 16. Oh, square root of negative 16 is we're back to square root this time. I had cube root stuck in my head, which is it's dangerous. You do get things stuck in your head. You really have to throw everything out after almost every problem, but make sure it's accessible. You know how you make sure that memories and skills and habits are accessible? By doing them over and over and over again, all right? It doesn't matter if it's sports or music or art, drawing with your hands, or math. That old saying, practice makes perfect. I wouldn't go that far, because perfection doesn't really exist, even in nature. So I would just say that, practice makes things go smoother and makes your skills a lot more accessible. All right, so negative 16x, the square root of that negative 1 is I, the square root of the 16 is 4, the x is still left under there, so we end up at A. All right, 2 more. And this one says no calculator, even though it's in the middle of the calculator section, all right? I didn't create these flip charts. I created the next ones that we're going to do. So I found this one to be a little bit tricky. I went ahead and calculated that without squaring anything yet, okay? Let's go ahead and calculate that. So that ends up being square root of negative 9 is 3i. 3i. So we have the parentheses squared. I'm just going to rewrite what's in the parentheses, because when you square something, you just multiply it by itself, all right? First, outers, inners, last. The I squared turns into a negative 1, which makes that plus 9 a minus 9, so therefore the 9s cancel. We combine the middle-like terms, we end up just with 18i. So we're going to go with A on that one. One more. And it is not terrible. It even tells you what to do. This one even tells you exactly what to do, all right? So, what is the resulting equivalent equation after multiplying both sides by 12? So we're going to multiply both sides of this equation by 12. I'm just going to leave some room so that I can work fairly quickly and just kind of mark stuff out as we go. Multiply both sides by 12. I could have just put some big parentheses like this and just put a 12 out here. Sometimes I do it like that. All right, when I multiply this 12 by this x over 3, the 12 and the 3 cancel and end up with 4x. The 4 is on top because the 12 turns into a 4 and it's 4 times x. When I multiply that by that, I end up with 3. That cancels with that. I end up with a 3 right here. So I have to distribute. So my 3 is actually here in a way. This is a little confusing. I know 3x minus 4, but it ends up being minus 3x plus 12 equals 24. 4x. Oh, okay. That didn't even take it any further. They didn't take it any further. They were just looking to make sure you could keep up with all those signs, which is tricky on that problem, all right? Not going to pretend it's not. All right, and that is it for this set. I'm going to go on to the next set, which is EOC Subpart 3. That's assigned to you, I think, on Friday the 11th, at which time that'll be our first full day in Rome, so we'll be very excited to roam around as it is. And I've told my family that I'm only going to use when in Rome about 4 times while we're there. So I'm allowed to do that dad joke about 4 times. Yeah, hey, guys, when in Rome. So you'll appreciate that. All right, I'll try to send some pictures in the email, but we're going to be pretty slammed the whole time. But we will see what happens. Thank you, guys. We'll talk to you soon.